So same process. If I show the assembly navigator now, so nothing can happen to this guy. Nothing happens. So once I click OK, you will see a lot of files are created. Actually, the duplication. Software have a library, have a template. Once you click OK, all the templates will be copied over. That is what they did. Okay, so we need to sit through and just roughly check what we're doing now. The product, only one. So selected. Project setting for path, I mean the file location. For example, for me, I file location more Wizard2 under this folder. If you want to change, you can change it. File name, now you still can change one name. Okay. So material you can change to other ones. Okay. So far I only have nylon. So I use nylon for this product, for example. I want a shrinkage, you can key in at this step. For example, what's a shrinkage for nylon? 2%, only 2%. 1.02. So configuration, I'm not sure it's at one. Attribute settings, millimeter. Okay, this one is just image, target. Otherwise, it's more steps. Okay, so we have this file, product. We have the file location. We have a project name. Once in the file name, it will appear as a project name. Okay, we have the material, roughly material for this product, shrinkage ratio for this product. Okay. Okay, again, when I'm doing the more design, I should know the product orientation inside the mold. The product orientation inside the mold. So the same vector direction. So where is a Z direction? What's a Z direction? So according to current image, so this Z direction is pointing upward. But for us, that will be a problem. Because I cannot eject the products follow this direction. So I need to rotate, right? I need to rotate. Okay, that is something we do here. So you can you can manually rotate this WCS first. Then go to here and let the system remember that. That is the concept. So we click on this WCS, click. So now you rotate a bit. You drag this small sphere and rotate by 90 degrees. 90 degrees. Okay. That means if this is my product orientation inside the mold, so I have no problem for ejection. That should be the correct orientation for the product. Now we go to here. More coordinate system. So I will let the system remember. Please use this current WCS as the more coordinate system. That is the meaning for doing the step. Okay. By doing this, you see, this one already rotated. Now you can click the home button and take a look. It's correct. This step is easy but critical. It's really critical, just like the shrinkage. It's very simple but important. So now we go to this shrinkage. You want to change? Just now I key in 1.02, remember? So now, if I want to change, you can change. I change 1.01 now. So in later part, for example, if you want to change the printing in later part, even after cutting, you still can come back to this place and change it. So, okay.
อันนี้ปรับจะสังเกตเป็น
So we have used the first button, second button, no, yes, sir.
ตอนนี้เราจะเป็น2ปุ่มแล้ว
Fifth. So now we need to go to define a block.
ปุ่มที่
Define a block.
เป็นปุ่มที่ใส่บล็อก
So most of the time I don't change it because I can change this kind of size at any time. Anytime. So I just click
ตอน
OK.
นี้ workpiece สามารถที่จะ
So if the block is big enough to cover up the product,
บล็อกนี้จะ
that should be
มี
okay for cutting.
พื้นที่ไม่
For this
ต่
cutting process. Okay, next one will be layout. Layout.
ำก่อนนี้ที่จะ
Oh,
ทำ
that's
ให้
nice.
ปรับ
This profile, that's like what they're showing in the profile. So click layout. So you're going to design one cavity more or two cavity
จะทำ1 หรือ 2 โหมด
or more. It can be 8 cavity.
1 ถึง 2 cavity
I have some question about
This is
last command to workpiece.
workpiece. You click workpiece and click OK. Then
Oh,
it's
I didn't
process.
know
You just
that.
What that mean? The limit.
limit
Distance limit. Select curve. That is something about is a Z value or X value. You find out is a Z value or X value. You click OK, accept first. Then later on you can change it. So if I want to design a 2 cavity, so I need to define. So where is the next cavity? One more cavity, right? One more product. Where's the location for the other or the second product? So I need to decide. So I need to specify the location of second product. For example, now I want to do this. Click. Or you want to put the other one on the other side. So you reverse it. You reverse it. So do you want to keep a gap? So side by side or want to keep a gap between these two insert? Also possible. So you can key in the value here.
ตั้งค่าเก็บระยะห่างข
All
อง
the settings are done, so we can
กรรม
start
ที่
the
แล้ว
layout.
กับอีกกรรมที่หนึ่ง
Because this is pointing to this left, right? This is pointing to left. So the second product will be placed at this location. Because it's rectangular, so if we follow X and Y direction. And for if we follow this direction, we have 2 counts. For this direction, we only have 1 count, so 1 row. Because it's balanced, when they put the other product here, so they need to rotate. That's the meaning of balanced over there. Balanced. Rectangular and balanced. The cavity count is 2. So the last step under this page will be auto center. Auto center. Because this 0 point will be a 0 point for the mode base. Will be a 0 point for the mode line, the whole mode line. So we try to locate everything according to 0 point. So now we close it. So by doing this, I think now we are able to decide the mode base size. We have certain catalog here, some catalog here. So this is one of the supplier. It's called Hasco. So these are the mode base size. Can you see a number here? These are talking about the size. Different sizes. So we need to do some calculations. We're using this you need to do some calculations. And by now, we are able to do this kind of calculation because we have the overall size for this layout. Overall size for this layout. The Mobius plate, of course, must be bigger than the insert and have enough space for grabbing gados and some other like cutting locks and other standard components. So we are here now, right? So we can skip, go to the next one. Cutting tools. Why this one never go text? This one will text. Okay, never mind. If it's doing like this, I'm trying to define the vector. So more cutting tools. The first one, analyze the region. So where the draw direction, I mean the ejection direction. Ejection direction. So I will define this will be the negative x. I will try to use that. So negative x. Okay. Yeah. So you can see our white color vector, white color virtual vector. Okay. So can you see this page? The dialog. Dialog. This is talking about the region. Region. Remember yesterday I draw a very simple product talking about the cavity side and
part for radiation.
So these are talking about this region. So how many surfaces for cavity region? So the system counts and tells us there are 70 surfaces for cavity and 102 surfaces for pond. So now we can set the color. Right, so here's the color change. The surfaces color are changed according to this definition. Of course, this product is more complicated than yesterday's product. Yesterday's product, we have the cutting line like this, go around and come to this point, go up, come down. Go to this end, you see the same thing happening here. Right? These are important dimension for more design and machining, because these are the fitting or matching dimension. That means I need to create a profile on core insert. Might be protrude out. So I need to create another profile recess in cavity insert. And these two dimensions must be matched. Must match to stop the plastic. So now this one okay. Just like what we done yesterday, you can try to change it, change color, and take a look. Check. Always check. So cancel this. So now we patch the surface. So all the internal loops, all I call it openings, all windows are selected, right? So many loops. How many? 14 loops. 14. So we just use auto patch. Select body. We now you select. Okay, there. We just apply. Okay, already finished. So you can see so many surfaces are created for us. These are the surface. How is much faster than manual method. Okay, the next one is define regions. Define regions. So we need to create a region and then create a parting line. I think we just follow the same step. So this one will be U region 0, call region 1, 2, 2. Okay, good. Apply. Okay. Now the parting line are created. I see this line are overlapping on the edge. Just placed on the edge, same edge, parting line. Okay, next one will be design a parting face. Design a parting face. Yesterday we have a planar parting face, so it's very easy to create. But today we have different face. We have different face. The parting line still is one loop. It's a continuous one loop. Okay, you can start from any point. You will go around and come back to the same point. There is a loop. It's a loop. But for this parting line, we need to do something. For example, because I know the system will create the parting surface using certain command, certain modeling command. That's why if you are doing this small design, you should be very familiar with software function. Okay. So now we need to define. I will define and let the software to create this parting surface using different commands from the other part. Because this part are the planar face and this part is not. So we need different method. Okay? So for this we need to edit parting line. Edit parting line, for example, select parting lines. Edit parting line segment. This is edit parting segment. Transition curves. Select transition curves. Transition curves means if I start travel from this point, go to around, then come to this corner, it will go up. So I call this 1, 2, 3 edges as a transition curves. So I will check. Select the transition curve, so we need to select. So pick 1, 2, and 3. This is one of the transition curve, and this will be the other one. 1, 2, and 3. So I have 6 transition curves. Apply. So you can see the color are changed. For the planar face, see the red color, and for the transition curves in the light green. So now the software will choose this. This is extrude. Everything is extrude, run extrude. You can use a planar bounded plane. Yep, bounded plane. Because it's a planar face, it's flat, so I will use this. Most of the time, system will decide fast. At this time, it's not, so I choose this. This part, I need to enlarge. Remember, enlarge this main parting surface. How large? As long as this surface is big enough to cover up the block, you can stop. Or the other way, any other method. Okay, now we just draw something like this. Cover up the block. Because later on, we will use this kind of chip body to trim the block. So this one must be bigger than the block size. Okay. So we will accept it. This guy will create this part. What's the meaning? Just now we have 2 arrows, right? One arrow pointing to here, the other pointing to here. So this arrow connect with the parting line. This part of the parting line. will split the planar face in two halves. Of course, we will keep one side and discard the other side. And by the suggestion, by the suggestion of system, I think it's wrong. So we need to flip. We will take the other side as our main surface. That's the meaning. Okay. Okay, now if this is the correct surface for us, you can accept it. Then we jump to the next segment. We will jump to the next segment. Of course, you are using extrude in, or if you are using a swap, or using the planar, the bonded plane, or a large face, up to you. Here, I still want to use this because this is a 2D curve. 2D curve. So I will use bonded plane. And same method, I just cover up. Can be bigger. Actually, now it's already enough. You can cover up the whole block. Okay, cover up the whole block. Then apply. Looks right. Looks right. So you just click OK. Now you flip. If you flip it, you go to the other side. So it's wrong. So you take it. Then how about the gap in between? The system will do fast. Okay, right? So far. So we finished our parting creation. So now I want to do a checking before I do the solid parting. Do I have the product? Yes. Do I have the workpiece? Yes. I show. Do I have the parting surface? This is the parting surface. Right? Do I have the patch surface? The small surface? Small surfaces? Yes. Do I have the cavity region or core region? Definitely have. Right? That means all the elements are ready. We can go to next one. Define cavity and core. So this is the solid parting. We just go to all regions because we should be very confident about this. Because no warning, no error. We can go to all regions and click. This will be the cavity surface. Yes. And this part will be the core insert. Yes. Okay, after this, you can go to show the top DOP. This is a template, so top. So we already finished our cutting. We already finished our cutting. And you double click on this top. This will be the one. Yes. Then you can proceed with other things. You want to modify the corner. You don't want this two side surface touching to each other. You can make a clearance. Yeah, up to you. Right? Because we are saying this, you will realize. Will be height. So these are the solid insert. This side surface, see, just match under 0. So by normally we will offset this side surface inside a bit. Can be 0.5 mm, can be 0.2 or 3 mm. I think will be good enough. But you want to cut away more, 5 mm inside also can. You just to make some clearance. So the next part will be the runner design, gating design, injector design, more and more details. This is the first step. cutting process. We should have this before we proceed to others. Okay, we can cut out. We can cut out. Okay, these are the videos from YouTube. That's a very brief introduction on molding machine.
In this section, we will cover some of the basic components of an injection molding machine. The base supports the molding machine and houses many of the machine's components. The hopper holds and funnels the plastic material into the barrel. The barrel houses the screw, which melts the pellets and forces the plastic into the mold. The barrel is surrounded by heater bands, which help maintain the barrel temperature. The clamping unit contains two large steel plates called buttons, on which the two halves of the mold are mounted. The machine clamp is used to open and close the mold. An ejection system is used to remove the part from the mold after it is formed. The control panel is used to set up, monitor, and manage machine functions including speeds, pressures, times, mold open and close, part ejection, and the temperature of the plastic material. An injection molding machine has three modes of operation: manual, semi-automatic, and automatic. The manual mode allows the operator to control each individual machine function. This mode is used when the machine is either starting up, shutting down, temporarily paused, or when adjustments are being made to the mold. Manual mode is also used when purging material from the barrel. Most modern machines are equipped with an auto-purge function. Specific functions such as opening and closing the mold can be controlled using buttons or switches on the control panel while in manual mode. The set or mold set option can also be activated in the manual mode. This setting allows for the fine-tuning of mold parameters using significantly lower speeds and pressures. Mold setup and maintenance personnel use this option to help prevent damage during mold changes. When placed in the semi-automatic mode, the machine runs one cycle and then stops. The semi-automatic mode is used when parts need to be manually removed from the mold during the startup process and when troubleshooting defective parts. After the mold opens, the cycle stops. The operator then opens the safety gate, removes the part, and closes the gate. Most machines will then begin the next cycle, yet some machines may require the operator to press the start button while in the semi-automatic mode. When the machine is placed in the automatic mode, parts are molded continuously. This mode is used for molds equipped with ejection and processes that use robotics. It is recommended to use the automatic mode whenever possible, since minimal operator attention is needed. Illustrates the basic functions of an injection molding machine and the process by which plastic pellets are transformed into molded parts. Pellets are fed into the hopper. A screw conveys and melts the pellets within the barrel. Melted polymer is forced into the closed mold. The parts are formed. The polymer is cooled within the mold. The mold is open. The part is ejected or removed from the mold, and the next cycle begins. It is important that production personnel are able to recognize common molding defects. Excessive unwanted material located on the edge of a part is referred to as flash. This is a result of material passing between mold components, usually the parting line. Flash most commonly results from high injection and packing pressures or low clamp tonnage. The incomplete filling of a mold cavity is called a short shot. Increasing the amount of plastic entering the mold during injection or cleaning the mold vents usually corrects this issue. Designing and constructing an injection mold can be an expensive and time-consuming process. Molds are extremely valuable tools that must be properly cared for before, during, and after production. But general mold maintenance can help avoid costly repairs and retooling. Before a molding operation begins, the mold should be closely inspected for any damage such as cracks, leaks, or rust. All moving components should be checked for excessive wear. This is usually evident by streaks or grooves, and if found, should be repaired by a trained professional. Most molds contain venting on the cavities, runners, and gates, and should be thoroughly cleaned with a cloth rag or a cotton swab.
ในหมวดการที่ครูเนี่ยคือมันจะทำให้ไอ้ขั้นตอนเมื่อวานที่เขาทำให้ดูคือแบ่งกราวิตี้รีเจียนคอรีเจียนเพื่อว่าตัดบล็อกให้ได้เป็นส่วนครับซึ่งคือต้องทำก็คือตอนนี้สิ่งที่ต้องมีก็คือเนี่ยสองตัวเนี่ยตอนนี้พาร์ติ้งไลน์ไม่มีครับตัวพาร์ติ้งเซอร์เฟซไม่มีผ่าเซอร์เฟซก็มีเพราะนั้นตอนนี้ยังตัดบล็อกที่เราสร้างขึ้นมาแล้วนี่ยังไม่ได้เราเลยจะเป็นจะต้องสร้างทั้ง3อันนี้ได้ก่อนอันแรกเขาเลยให้มาเริ่มที่เนี่ยที่รีเจียนอนาลิซิสก็คือในตรงรีเจียนอนาลิซิสนะครับมันจะคำนวณถึงทิศทางของการปลดเป็นหลักซึ่งตอนนี้จากรูปก่อนนั้นเนี่ยจะได้หมุนแก๊สแล้วถูกไหมแต่พอกลับมาอยู่นี่ใหม่มันยังเอารีเจียนรูปเก่ามาใช้เพราะนั้นตอนนี้มันต้องหมุนไปทางแกน x ลบแทนใช่ไหมจากก็ไปเลือกตัวเวกเตอร์ x ลบเป็นด้านปลดซึ่งที่มันตรงกับตัวที่เราเลือกไว้ในตอนแรกครับก็คือตัวด้านปลดก่อนหน้านี้ตามที่เราตั้งที่ตรงรีเจียนตอนแรกครับก็เลือกมาตรงกันครับเพราะฉะนั้นตอนนี้แกนมาตรงกันเรากดโอเคเอาแกนตัวนี้ครับก็คือตรงแกนนี้ครับอันนี้มันแสดงตัวที่ทางปลดไว้ครับถ้าตัวนี้ที่เราเลือกไว้ตัวสีเหลืองขึ้นมาใหม่นี่คือตัวที่เราเลือกแกน x นะครับแกน x ลบพอเรากดโอเคมันก็จะเป็นจุดเดียวกันนะครับแล้วเรากดโอเคมันก็จะสามารถทำการหาทิศทางด้านปลดได้มันก็จะเริ่มคำนวณหารีเจียนทางกราวิตี้กับคอได้ซึ่งตอนนี้นะครับเราพบว่ามีกราวิตี้รีเจียน70ลูปแล้วก็มีตัวคอรีเจียนอีก120ลูปที่เป็นเส้นต่อกันเพราะฉะนั้นที่เขาทำก็คือเขาเซตตัวรีเจียนทันเลยก็เพื่อเราเห็นแยกระหว่าง2ส่วนก็คือส่วนใหม่ก็คือตัวคอรีเจียนจะเป็นสีน้ำเงินกราวิตี้รีเจียนจะเป็นสีส้มอันนี้มันตั้งเองใช่ไหมครับอันนี้เขาตั้งไว้คือเราอาจจะพลิกพอยต์เลือกสีต่างหากก็ได้ครับคำว่าจะเลือกสีก็ได้แต่ว่าตอนนี้คือผมใช้ค่า default จากเขามาลองเลือกดูก็จะได้เป็น2ส่วนแล้วกดพาแล้วกดแคนเซิลนะครับเพราะนั้นคือจะเห็น2ส่วนแล้วนี่คือจะรู้รีเจียนว่ารีเจียนส่วนนี้เป็นของตัวกราวิตี้รีเจียนแล้วก็ตัวคอรีเจียนนะแล้วเสร็จปุ๊บเราก็จะมาทำในส่วนถัดไปคือตัวผ่าเซอร์เฟซซึ่งไอ้ผ่าเซอร์เฟซตอนนี้ครับมันหมายถึงในส่วนที่รูที่เป็นต้องปิดบนหน้าเซอร์เฟซในแนวทิศทางการปลดครับในแนวแกนแซที่เราทำเมื่อกี้คือว่าจะเป็นจะต้องปิดรูตรงไหนบ้างเพื่อไม่ให้ว่าไอ้ตัวเนื้อพลาสติกมันไหลเข้ามาเพราะนั้นมันจะคำนวณให้ตอนนี้มันมีอยู่52รูที่เราทำงานปิดเนี่ยเพราะนั้นคือเราแค่แอปพลายกดโอเคแล้วแอปพลายเข้าไปมันก็ทำการปิดรูครับเพราะนั้นบางส่วนมันอยู่บนคอรีเจียนอย่างเงี้ยอยู่บนคอรีเจียนนะบางอันที่อยู่บนไดบนกราวิตี้รีเจียนเพราะเนื่องจากมันปิดด้านบนด้านล่างไม่เหมือนกันมันแล้วแต่ที่ไอตัวมุมการปลดเนี่ยถ้าเรามองภาพด้านหน้านี่เราเห็นว่าด้านนี้มันเป็นมุมสโลปมาอย่างนี้ก็เลยจำเป็นต้องปิดอันนู้นเพื่อให้ปลดออกอย่างนี้ได้ครับพอได้เลยครับพอนี้รู้ได้รูปแล้วส่วนที่มาทำต่อคือเรื่องของตัว define region ซึ่งไอตัว define region เนื่องจากรู้ทั้งส่วนที่เป็นตัวค อรีเจียนส่วนหนึ่งแล้วก็ตัวกาวิตี้รีเจียนเพราะนั้นที่ต้องทำก็คือเราจะทำตัวพาร์ทติ้งไลน์ซึ่งเราขาดอยู่ตรงนี้ที่ผมบอกเมื่อกี้ครับที่เราขาดอยู่ตรงนี้มันก็ยังทำไม่ได้ครับเพราะนั้นให้เราเขียนรีเจียนกับตัวพาร์ตติ้งกับพาร์ตติ้งไลน์ซึ่งไอเขียนรีเจียนนี้ก็จะเขียนทั้งตัวกาวิตี้รีเจียนแล้วก็ตัวคอรีเจียนด้วยครับพอเรากดโอเคเข้าไปมันก็จะคำนวณหาให้ครับซึ่งถ้าอาจารย์สังเกตเห็นเส้นตรงนี้มันจะเปลี่ยนสีไปไหมครับเส้นตรงขอบมันจากเดิมเมื่อกี้เป็นสีดำทึบๆมันจะเปลี่ยนเป็นสีเส้นสีทุนนี่คือมาคำนวณแล้วก็คือตรงนี้เป็นพาร์ทที่ไลน์ของเราแล้วก็ด้านบนของเส้นเป็นตัวขอบเป็นตัวกาวิตี้รีเจียนแล้วด้านล่างเป็นคอรีเจียนเพราะฉะนั้นที่ต้องทำต่อคือเมื่อวานได้พาร์ทติ้งไลน์แล้วก็คือส่วนที่ทำต่อคือต้องทำชีทเพื่อมาตัดไอ้บล็อกที่ว่านี้เป็น2ส่วนครับเป็นกาวิตี้รีเจียนส่วนหนึ่งแล้วก็เป็นตัวคอรีเจียนส่วนหนึ่งซึ่งปัญหามันคือนี้ครับปัญหามันคือว่าเนื่องจากเมื่อวานมันเป็นแฟลตเพจครับมันเป็นที่เราฉีดที่งานมันเป็นแฟลตเพจคือวันนั้นเราใช้แผ่นเรียบตัดไปเลยครับแต่ปัญหาว่าตอนนี้คือว่ามันมี2ส่วนครับก็คือมีตรงมันมี2ส่วนที่เราต้องอาจจะต้องแก้ไขคือเนื่องจากตอนนี้ส่วนขอบทั้งหมดนี้คือผมขีดอยู่นี้เป็นแผ่นอยู่ครับแต่ส่วนบางอันมันยังมีส่วนนึงเข้ามาเป็นบอลเข้าไปในเนื้อบ้างผมก็จะเป็นต้องไปทำในส่วนของ3พวกนี้เนื่องจากตัวนี้เราจะเป็นต้องเพิ่มเซกเมนต์ในส่วนของ2ส่วนครับที่เป็นตัวนี้ใช่ไหมใช่ครับตัวแผ่นเดิมเมื่อกี้ก็คือที่ต้องทำคือไปเข้าไปที่ดีพาร์ตติ้งเซกเมนต์ครับแล้วก็เลือกไปตรงส่วนที่เป็นส่วนเคิร์ฟเพิ่มตรงนี้ครับก็คือด้วยคำสั่ง section select transition curve นะครับซึ่งเราเข้าไปเลือกครับก็คือเลือกบนเส้นขอบเดิมที่เขาทำครับไม่ใช่เลือกสีดำนะเลือกเส้นสีครีมเนี่ยที่เขาเลือกไว้ก่อนหน้านี้แล้วก็เลือกให้ครบทุกเส้นเนี่ยก็คือเลือกบนเส้นขอบตรงพาร์ตติ้งไลน์
ต้องเลือกทั้งหมดเลย
ก็คือเลือกเฉพาะขอบที่เป็นส่วนที่เว้าประเด็นนะครับ
ก็3เส้น
นะครับแล้วก็ตรงส่วนของโค้ง
แล้วมันเกิดจากเคิร์ฟเดียวเลยป่ะ
มันประกอบด้วย3เคิร์ฟครับมันมีส่วนตรงส่วนหนึ่งก่อนนะแล้วก็เป็นส่วนเคิร์ฟพอเลือกได้ก็จะมี6ส่วนพอเลือกได้เราลองแอพพลายดูจากก็จะพบว่ามันจะมีเซกเมนต์เพิ่ม2อันเซกเมนต์อันนึงก็จะเป็นเบอร์1ก็จะเป็นเซกเมนต์ตั้งแต่ตรงส่วนนี้ไปถึงส่วนขอบนะครับเซกเมนต์ที่2ก็จะเป็นตั้งแต่transition curve ตัวนี้มาถึงตรงนี้เคิร์ฟนี้ครับเพราะนั้นคือ2ส่วนนี้เราก็ต้องมาทำเป็นตัวชีทบอดี้ที่ไปตัดตัวครับเราใช้คำสั่งตัวบอลเพนหรือตัวเอลลาร์เนี่ยขยายตัวชีทมันออกมาซึ่งวิธีการก็คือแค่ขยายตัวชีทนะครับให้มันเต็มบล็อกเพื่อมันตัดได้แค่นั้นพอ
อย่างนี้ได้
นะครับพอได้ปุ๊บจานเรากดแอพพลายดูเพราะนั้นก็จะเห็นเป็นตัวแผ่นหนึ่งสำหรับด้านตัวที่เป็นตัวเซกเมนต์แรกครับถ้าได้ปุ๊บการกดเดทบางอันมันจะเป็นอย่างนี้บางทีเราทำมาแล้วเป็นนี้แต่ก็ใช้คำสั่ง10ทิมชีทก็ได้มันจะกลับด้านได้2ข้างพอจะกดโอเคปุ๊บมันก็ได้เซกเมนต์แรกจะเป็นเต็กถูกครับทีนี้ก็ยังเป็นเซกเมนต์ของตัวเตือนหรือเราทำเหมือนกันใช้คำสั่งเอ็นลาร์เหมือนกันเนื่องจากเป็นเพจเรียบๆแล้วก็เอ็นลาร์ขยายมันเหมือนกันครับ
ก็ให้ใหญ่
ขยายให้มันใหญ่กับบล็อกไปใช้ได้ครับจะลองแอพพลายดูมันก็จะขึ้นครับเพราะนั้น2ส่วนเซกเมนต์2ส่วนก็จะจัดการได้แล้วพอจานกดโอเคถ้าจะคิดว่ามันใช่แล้วจะกดโอเคแต่ก็จะพบว่ามันจะสร้างส่วนที่เป็นตัว transition curve ไปเองครับพอเราดูภาพ3มิติเราก็เห็นว่ามันทำส่วน transition curve ทั้งหมดให้แล้วแต่ก็คิดสนุกได้ครับเพราะฉะนั้นหลังจากนี้คือเราก็ไปทำในส่วนของตัว create ตัว gravity core ได้เลย
เราข้ามตัวนี้ไป
ไม่ต้องตัวนี้ต้องทำไอ้ตัวนี้คือหลังถ้าเราทำแล้วไม่ได้ต้องมีการ edit คือเข้ามาโหมดนี้ edit ตัวครับเข้ามา edit อาจจะปรับแต่งตำแหน่งแต่ตอนนี้ได้แล้วก็คือมาทำที่นี่นะซึ่งเราจะเห็นว่ามันไม่มีตัวแดงเตือนนะแสดงว่าตัวคาร์ดมันใช้งานได้แต่ถ้ามันมีตัวเตือนปุ๊บอาจจะต้องมาใช้คำสั่ง edit แกนใช่ครับก็คือพอถ้าได้แล้วแต่ก็ไปที่ origin ครับกดโอเค region แรกก็จะไปทำในส่วนของตัว gravity region ให้ก่อนครับถ้าได้แล้วแต่กดโอเคทีมันก็จะไปทำตัว core region นะครับเป็น2ส่วนพอจะโอเคมันก็จะกลับมาที่รูปเดิมคือตอนนี้สามารถสปลิตไป2ส่วนได้แล้วพอจะดูเข้าที่ Windows ครับกด Diet Top 010ครับมันก็จะแสดงตัว region ทั้ง2ส่วนครับถ้าเราลองหายมันดูเราพบว่าก็จะมีชิ้นงาน2ชิ้นถ้าเราลองหายดูทีเราก็จะเห็นตัวนี้ก็จะเห็นตัวกับตัว core region ซึ่งมันจะเห็นจากสีที่เราเห็นครับ
ถ้าจะเปิดให้มันมาครบเนี่ยเปิดตรงไหน
edit ครับแปมสั่ง show and hide เลือก show all มันจะกลับมาเป็นเหมือนเดิมครับ
แม่ดูอยู่2 วันนี่ก็ยัง
The direction of Z is just nice, right? Direction of the Z axis is just nice. And the level of XY plane is also just nice. At the same level with this planar face. Same level. Same level. That's nice.
สัดสีขึ้น
I think that is
ถือ
good
ว่าใช้
enough.
ได้แล้ว
So later on we can proceed with more wizard. Now I close all the product. Close. And make sure you need to create a new folder for this file. New folder for this file. Now we can go to this, load the products, and this is the more wizard 3. That is the product. Okay. And the place normally is correct. Then the file name, game control, the material you can put or don't put. The shrink gauge, for example, I want to put 1.005. Okay. This will be the one. So now you just need to proceed to the next one. 1, 2, 3, 4. More coordinate system. So I will use the current WCS. If not, we can modify it. We can shift, we can rotate. Then let the system remember using the WCS. You go to next shrinkage, you want to change. If you don't want to change, skip it. I already clicked in the 1.005 just now, right? So skip it. Go to workpiece. We define a big block. And this block must be able to cover the whole product area. That is good enough, right? So you can see these lines. It's talking about the overall size of a product. Based on this, plus the allowance. Okay. Is that okay so far? Okay, yeah. The next one will be the layout. You are going to design 1 cavity or 2 cavities. 2, okay. So we have a 2, so we put 2. I want to put the other one. Okay, where you want to put the other one? On the screen is left or right? Right, here, right? Okay. So why I want to put here? Because by looking at this profile, I will know this product will be looks like this. This is the product profile. Whereas by doing the more cutting, this will be the cutting line level, and this will be the insert, and this will be another cutting line level, and this will be the other insert, and these are the cutting lines. Cutting lines, cutting lines. Right? Yes. So I want to put another one like this. So when I design the screw bush, runners, so everything will be balanced. Everything will be balanced. That's nice. That's why I want to put on this side. So I need to define the direction. Balance, okay, specify the vector from this direction, but reversed. So start the layout. So I have another one. Then put the 0 point to the center of the overall size. So set. That will be the one. So the balance is one is talking about this angular balance rotate, copy over and rotate, or balance. The other one is when the cavity and core are fully filled with the plastic. Actually, we have certain pressure. So this pressure will intend to open this insert. Right? If we only have one cavity, so this force will work or will transmit over to the mold base, and this kind of force will share the gravity and garbage. So if we have two, we hope it's just well balanced, so we can have a longer true life. And if you still worry about this, it's okay to add in some locking system in your mold base, so as we can protect our mold base and prolong your true life. That is some considerations. We are here. Okay, now we go to the next one. Already here, so I need to pay the loans. Okay. Okay, you need to analyze the regions. Big. This time I think it's very straightforward. We need to follow this direction. So sometimes this arrow will hit other object and it's not the correct location or direction. So I prefer to click on this, identify. Like this will be 100% correct. Accept. We have the non-parting surface, non-parting curve, or we call parting line, and the small openings, right? We can consider this the opening holes for the buttons. So this is a game controller. So buttons. So cavity core, okay, undefined region is 0, and it must be 0 before you proceed to the next step. Now we set the color. Okay, setting this color doesn't mean we've done the region analysis. So far, the software still can't remember. The software still don't know what other cavity, what are called. So we need to accept this and go to this later on. Must click this. Now, of course, now the step to do the patch. We have 1, 2, 6. 1, 2, 3, 1, 2, 3. Okay, 6. Just apply. So if you find sometimes maybe something wrong with one more batch, so you can go to this and edit, delete, and reconstruct manually. I don't think that's a big problem for you. So next one will be this. Let the system know what we did. So create regions. So the other way, you can check. Do we have region? So far, no. Do we have region for core? So far, no. Right? That's why come here and create region and create a parting line. Okay. Now we check it one more time. Region. Should I call region? Yes. Next one will be the parting line. Non-parting line. I think non-parting line for this part is quite. We also need to define the transition object. Because we have one part of the planar parting line, and And this also planar parting line, this planar parting line, and this one is transition. And this part also transition like we need to do something. That's right, that's right. If we can do a short time. To create the parting surface, currently this is a completed loop. Completed loop. So I need to define some transition curves. Up here, this will be one of them. Yes. This will be the other one. And this will be a few more. Yes. Right. So apply. Apply. So currently this system will jump over to the first curve. So now I want to use which one? Okay, because it's a planar surface, so I will use the bounded plane for this part. And for direction, is there any number 1 and number 2 appear here? No numbers, never mind. Because I know I want to create a surface cover up of this part. Cover up this part. So I need to find the first direction. Let's take a look. X direction, you're wrong. So we need to pick on the Y direction, Y negative. And second direction will be Y positive. And make this one bigger and to cover up the block. Yes, good enough. And apply. Check. Should be okay. Should be okay so far. So we accept. And this guy will jump over to the other one. So I want to define this. I will click and I click so much. I will use the bounded plane also. Let me take a look. How is it? So this arrow should be okay. I can extrude along this direction. How about this part? Can you extrude to this direction? Okay. So we can go to bounded plane, and for the first arrow, I want to follow Y. Yes. And for the other arrow, I want to follow X. Okay. So drag and enlarge the surface to cover up this part. So accept. Check. It's okay so far. Accept. Then we come over to this. We use the bounded plane again. Bounded plane again. Then go to negative Y. And this will be X. Enlarge a bit. Yeah, it's good enough. Enlarge a bit. Accept. Accept. Is that okay? So far this can go parting. Is that okay? Not good. For this part, not good. Understand? This part, not good. This part is okay. This one needs to go to the operation and the regenerator walk. So will be following the axis. still not following. Okay, so this learn parting already completed. But we need to do some modification because it looks like this parting is not perfect. It's not perfect. So we need to go to this guy. Edit parting and the patchy surface. So I need to remove. I need to remove this part. I need to remove this part. How to do that? This idea and patch up Okay. So now I think it's good time to go to this more tools. The other one is here. Let me check about this. Select parting line, that's all we can do. For this part, I will create this command. This is the one. This is the one. Edge patch. And this is the solid patch. This is the max solid patch. And the parting line is this. Okay. So I will extrude this edge along this direction. We'll go to extrude and then select this edge and define the vector. This vector will be y and select them. This time should be perfect. Apply. And this time for this one, the direction will be negative y. Apply. Apply. How about this part? Okay. You have different methods to do that, and I have mine. Let me think for how I will do this. I will create one line. How about this sketch line? Let's use it. So step on this end point. Draw the other, connect to the other point. Hold it. And that's like this. Draw a line. Finish it, then I will use, remember what we learned for the freeform modeling. So we can use a freeform model, insert, there can be the mesh surface, right? Or can be other tab. And this, currently I can use this true curve mesh. I need a true curve mesh. I will define this guy as a primary, this guy as another primary, and this 1, 2, 3, 4 as one other cross, and this guy with another cross. That is my thinking. Select primary curve. How are we going to pick anything? I just want to use one curve. Yes. Primary curve 1. And primary curve 2. This direction is just reversed, so I need to click. So this arrow 1, and this arrow 2. All the same. Okay, now we come down to cross. this will be the loss. So, okay, and add another one. Accept. So by doing this, I patch up the opening using a free-form modeling method. Okay. And last one will be this part. I think extrude will do this kind of job. So just pick this edge and define the direction. Vector direction is something like X. Now we can check perfect line looks like. How about this part? Also perfect line. The internal part should be okay. Or you can change the wireframe and then check. This one should be okay. But looks like a little bit of mismatch. Let's go to the center part. So now we check. Do we have the product? Yes. Do we have one piece? Yes. We do have the parting surface? Yes. Do we have the pipe surface? Yes. Do we have the cavity and core region? Yes. These are the necessary parts. Then we go on to the last button. All regions, one goal. Okay, the two targets do not form a complete intersection. I know what's that. So this is the patch solid, patch surface. Where are the rest? Oh,
Do you need to see it?
I need to see the file like. Never mind. I will do this part. So first, I need to extrude this guy according to y. So this, and then extrude this guy according to negative y. And the last part, I will take one line just like that. Cross. Add. The last part, extrude. And we do X. I need to save the file first. It's good to save it. Now after that, I will let the system know. These are the parting line. I need to click this, or this same. I can click this and tell them these four surfaces are part of the parting line. That's not I click, so that's why I was without. Internal menu. Very dangerous. I will check parting surface. Oh, some errors happen. Can I proceed? That means just now I should click on this button and tell the system these are the parting line. Then I can proceed to it. And now it looks like something. I make some mistakes now. With this software up to the file, and something happened. So I can proceed. let's try this step. We have this cavity region. One by one. Core. Deleted invalid class Now I will show the top. I will complete because of these two surfaces. Some error happened. Looks like I need to redo everything. But then it's better to use a more wizard. So we found something is not so good according to your idea, so you can modify it. Modify the array. So for example, just now I delete this profile, the internal this profile, right? Which was created by the system. According to our experience, this kind of parting surface will be better than the previous one. That's why I changed to this kind of shape. Because the insert will be quite solid with this kind of parting. So the other one, just now, you just extrude within these edges. Extrude these edges. So we are creating some very sharp steel over there. So I feel this is a better parting surface. That's why we change. But some mistake about the preparing